This question is asking us to find an equation of a line, but the slope is given. Previously we've been finding the slope on our own, but in this case we know the slope that we want. It's just a matter of finding out where that happens. So the curve is y equals the square root of x, and we know that the slope of the tangent line is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now in this case we want this slope equal to 1/4. So now our job is to find the x values where this occurs. So let's construct the limit statement and simplify it and then solve for x. The function is y equals the square root of x, so we have the slope of the tangent is the limit as h approaches 0 of the square root of x plus h minus the square root of x all over h. And we want to take this limit, but we can't make substitution, of course, because h is going to 0 and we get a division by 0 error. There are radicals involved, so the conjugate seems like a likely tool to get us there. We'll multiply the top and the bottom by the conjugate and simplify, and giving us the limit as h approaches 0 of, and we have to FOIL this, right? So this term times this term. So we do first leaves us with x plus h then the outer and the inner cancel. If you don't believe me, pause the video and try them, multiply them together. You have exactly the same thing about opposite signs. And then we multiply the last. So negative square root x times positive square root x is negative square root of x squared is x divided by h times the square root of x plus h plus the square root of x. In the numerator the x's cancel, that's handy, leaving us the limit as h approaches 0 of just h over h times the square root of x plus h plus the square root of x. And now the h's cancel. I'm going to pause for just a moment so that you can write what you think the next bit of the statement should be. What now are we taking the limit of? Sometimes students write just this business, the square root of x plus h plus the square root of x, because that's kind of looks like all that is left. However, this stuff was in the denominator and it must remain in the denominator. We don't get to give it a promotion to the numerator just because the numerator canceled. So we have this place value, this placeholder of 1 that says that stuff is still in the denominator. Now that doesn't hurt our feelings. We can still substitute, let that h go to 0. So now we see that this limit has a value of 1 over the square root of x plus 0 plus another square root of x, also known as 1 over 2 square roots of x. So that equation describes the slope of the tangent line to the curve, the square root of x, and we now want to know where this value equals 1/4. So where does 1 over 2 square roots of x equal 1/4? That now becomes the question. The slope of the tangent line equals the given value 1/4. So we can solve this by cross multiplying first. 4 equals 2 square roots of x, and then I would divide by 2, so 2 equals the square root of x, and square both sides, so 4 equals x. Now I know where that happens, so at x equals 4, the tangent line has a slope of 1/4. So now we know almost enough stuff to write the equation of the line. We simply have to know what the y value is that corresponds to the x value of 4. For that we use the equation that y equals the square root of x. That's the original function, not the derivative. So y equals the square root of 4 when x is 4, also known as 2. So now we have the things that we need. The slope of the line is 1/4, and it happens at the point where x is 4 and y is 2. So the point is 4, 2. And then we can write the equation of the line using this information. Y minus the y value 2 equals m, the slope 1/4, times x minus the x value of 4. And then simplify. Y equals 1/4 x minus 1 times the 1/4 plus 2 would be plus 1. So that is the equation of the line that's tangent to the curve, the square root of x, that has a slope of 1/4.